Have you ever wondered how researchers actually discover new knowledge? It all comes down to a simple, repeatable process known as the scientific method. Chapter 1. The scientific method, the big picture. The scientific method is a step-by-step approach to answering questions using evidence, not guesswork. The steps are simple. Step 1. Ask a question, something you want answered. For example, does sleep affect memory? Why do some people learn faster? Step 2. Form a hypothesis, a testable prediction. For example, if people sleep more, they will remember more. Step 3. Collect data. This involves designing a study or experiment to gather evidence. Step 4. Analyze the data. Use statistics to see whether the evidence supports your hypothesis. Step 5. Draw conclusions. Did the results match your prediction? If not, revise the hypothesis and test again. This cycle repeats again and again. This is how our understanding of the world continues to evolve over time. Chapter 2. Experimental design. How to test a hypothesis. When researchers want to establish cause and effect, they set up an experiment. First of all, an independent variable. This is the variable you manipulate. Second, the dependent variable. This is the variable you measure. For example, memory test performance. Third, controlled variables. Everything else should stay constant, such as lighting, time of day, instructions, environment. This ensures that any change is caused by the independent variable and not something random that you haven't controlled for. Chapter 3. Experimental groups. Most experiments include an experimental group and a control group. In the experimental group, the participants receive the treatment. For example, in this hypothetical study, they might sleep for 8 hours. In the control group, the participants do not receive the treatment. For example, they might sleep for only 4 hours. Comparing the two groups helps to isolate the effect. Chapter 4. Why good design matters. A well-designed experiment avoids bias, confounding variables, random chance, and misleading results. Good science is repeatable, transparent, and carefully controlled. And that's the scientific method. Ask a question, predict, test, analyze, and conclude. And of course, your conclusion can lead to new questions, which can then be investigated in a new experiment. With good experimental design, we turn ideas into reliable knowledge.